an hour here this morning. If I could ask those that aren't presenting to turn off their cameras and go on mute, that would be really helpful. Thank you. There is the opportunity to ask questions. If you go onto slido.com and put in hashtag 476710, that is this meeting here this morning, and you can post questions. And so I think it'd be quite nice to help to spice up the discussion a bit if you took that opportunity to ask those questions. We are recording this session so that we can make it available afterwards. So if there's anybody that's concerned with it being recorded, then please leave the session now. Otherwise, we'll carry on. So we've gathered together, I think, a really good panel for this this discussion here this morning. And so I'd very much like to welcome Barnaby Wharton, Director of Future Energy Systems at Renewable UK, Dr. Sarah Walker, the Reader in Energy at Newcastle University, Keith McLean, Managing Director of Providence Policy and a very active member of the community. And alongside that, Michael Smart, who's Director of Energy Transition Strategy at KPMG. And Michael is very much the engine and the power behind the analytics within the report. So if anybody has any deep questions around the data and the assumptions, then I'm immediately passing that to Michael. So welcome all panel members. If I start by just doing a 5-minute overview, and then we'll get into the discussion. So creating a system for all seasons. I mean, I like to think of this as it comes out of a frustration around the energy decarbonisation debate, and that people who are not involved directly in the industry think of the world in a very simplistic way. And actually those of us within the profession know that there is a complexity around the way that the systems are managed on a minute by minute, hour by hour, day by day, and across the seasons. And we do still see that within the way that, for example, the partially decarbonised power sector still relies on an element of fossil fuel, but even coal as well as gas. And I think we've moved from a coal-fired system to a coal-fired plus gas system to a gas system, renewables, and now we're pretty much on a 50-50 natural gas and renewable system. But as we move forward, we need to take into account that we need resilience of our energy system across all days of the year, under all climatic conditions, for all customers. So the system needs to work across the seasons and needs to work for all customer groups. So we set off that piece of analytical work and published the findings of it in October 2021. And for the first time, we've pulled together a number of pools of sources of data to look at the seasonal electricity generation and consumption trends across the GB energy system. It examines the wind capacity needed for 2050 to meet energy demand with and without hydrogen and hydrogen storage. It proposes an optimized energy system using hydrogen storage. So we've taken the data and then looked at, so how do we make this a more efficient, holistic system? And I think, you know, that is very much taking a systemic approach as opposed to a direct linear approach to the delivery of energy for customers. and it examines the potential for hydrogen storage capacity and options. And in doing that, it covers the nature of different types of storage that will be potentially available and necessary in order to create a balanced energy system. So next slide, please, Ed. So in creating a system for all season, the wind and solar farms could generate around 60 to 80 gigawatts of green hydrogen from renewable electricity generated between May and October each year. So that's a period where we have what we call a good quality wind resource, but without the electricity demand to achieve that. And that equates to a capacity of around, excuse me, 25 Hinkley Point C power plants. So an extraordinary amount of energy, and it will reduce the need for total electricity generating capacity of UK wind farms from somewhere around 500 to 600 gigawatts by 2050 down to 140 to 190 gigawatts. So a reduction of up to 76%. And that's to bear in mind that our current peak load on our electricity system is just under 60 gigawatts. So it gives you some context around the scale of things that are necessary in order to deliver the transition. So it takes 140 to 190 gigawatts of generation capacity and 115 to 140 terawatt hours of green hydrogen that would be stored. Enough energy for every person in the UK to charge a Tesla Model S for more than 21 times. That's assuming no battery degradation, of course, as you go through that. The potential hydrogen storage volumes from Britain's salt fields ranges from greater than 1 terawatt hours up to 30 terawatt hours. So a huge amount of energy storage potential. And from disused oil and gas fields, the potential storage volume for individual sites ranges from 1 terawatt hour up to 330 terawatt hour, depending upon the choice. So that's really the context of the document. Hopefully you've had the opportunity to read the document itself. I absolutely would recommend it. I think it does make a good read. So we're going to kick off this session with essentially 4 questions that I'm going to put to panel members. And I can see that we are starting to stimulate some questions coming into Slido as well. But the 4 questions that we'll start with are: what will be the most important interactions and their benefits between hydrogen and electricity in a decarbonised energy system? How can a decarbonised energy system meet peak heat demand? And what are the technical and policy challenges, the use of hydrogen for interseasonal storage? And then quite topically, given the timing of this webinar, what impact do we think the COP26 Glasgow Pact will have on the role of hydrogen in our energy system? So I'm going to kick off with the first question: what will be the most important interactions and their benefits between hydrogen and electricity in a decarbonised energy system? And Keith, can I throw that question to you in the first instance?
Yeah, thanks, Chris. And I think it is an interesting question. What is the energy system, and what's it based on? At the moment, most of our discussions tend to be rather electrocentric, and we talk about how we can use hydrogen within that system. But I think we also, as this report shows, need to think perhaps whether more of the thinking needs to be around what the hydrogen system would ideally look like. And one of the things within that I think is really important to understand and consider is what are we using mainly, or what are we using in certain circumstances as the transport and storage medium? And there, I think if we are transporting hydrogen in pipes and storing it in geological storage facilities, it really makes an awful lot of sense to do that. And when you look at the costs, it compares very, very favorably with doing any sort of transport or storage with electricity. And therefore, rather than saying how can we make hydrogen from spare electricity, or how can we use hydrogen to fill in the gaps when the wind isn't blowing, I think we should be looking at whether the system based on hydrogen, particularly for heat, should be the starting point for our thinking, because using hydrogen for heat can be done, even if it's being done by combustion, extremely efficiently, and so there's no need to electrify heat and then to use hydrogen to make the electricity to produce the heat. That really wouldn't make any sense. So I think we need to look at this with different eyes, and as I say, the main consideration should be the transportation and storage, because transporting hydrogen in pipelines shouldn't cost much more than transporting natural gas in pipelines, and for larger quantities that can be done at somewhere between a 15th and a 20th of the cost of transporting electricity. And we know that storing electricity is very expensive. And in the paper that I recently did with Grant Wilson at Birmingham University, we looked at this, and just replacing 1 day of natural gas storage with batteries would cost £1 trillion. Therefore, it's really important that we consider these factors when looking at the system, and that we have an open mind as to whether that system is electric, hydrogen, or some combination of both.
Thanks very much for that, Keith. Barnaby, can I throw that same question to you?
Sure, thank you. Good morning, everyone. I think my starting point, I think, probably very, very similar. I just sort of noticed when the introduction, actually got my job title wrong there. I'm Director of Future Electricity Systems. But I think the really interesting thing is that actually we had a debate previously when I got my new role about should it be electricity or energy, and at the time it was very obviously going to be, it was electricity. But actually over the past 18 months, this kind of interaction between electricity and the wider energy system, and these silos between electricity and heat and transport, have really broken down. So I think that kind of that interaction, and the role of hydrogen in particular in bringing together all of these sort of aspects of our energy use is really interesting, and it's kind of going to be, I think, how we think about the system in future. So I'm from Renewable UK. Traditionally, we very, very much focused on wind. And I love the report, and it's particularly in the fact that it's, it looks at a 500 gigawatt wind system, which many of our members would be hugely excited about. The opportunities there to deploy that much wind would be amazing. But it's not going to be, I think, the most efficient system we have, and the report makes that point very well. So for us and for our members, we are thinking much more about the role of hydrogen in the system because it offers so much to a high renewable system. There are going to be times when we are generating, even now, much more wind than we need, and other times when, we've seen recently, we're not generating enough. So how do we balance these periods? And hydrogen is going to play a hugely important role in that. And primarily because it does do that storage aspect that the other things don't do. And Keith, you were just mentioning that, that the role of batteries will be very important in the electricity system, storing electricity for hours, possibly days, depending on your battery technology. And that'll be great, and that'll make sure the electricity system and services around inertia can be delivered. But we won't see electricity storage being done for this sort of interseasonal, long-term storage where you're massively overproducing electricity during one period, and then requiring energy in some form later in the season. So that interaction is going to be hugely important. And the other thing I would say, these periods, as the report again makes clear, is there is this sort of correlation around wind generation. When the wind is on, it's really on. And that has that depressive effect on pricing and the price cannibalization side of things. So having a new form of demand essentially can shore up that price cannibalization, provide additional revenue streams, which actually then sort of conversely sort of provides reassurance to those investing in wind, and therefore, excuse me, bringing those costs of capital down. So these two things, I think, it will interact really importantly. And my battery's about to die. Sorry, nearly lost my computer there. So I think hugely important. I will leave it at that and just make sure my computer is happy.
We'll let you do that. And Sarah, if I can ask you, I was going to say for an academic perspective, but I don't mean it in anything other than a positive way.
Thank you. Yes, I think in terms of important interactions, what we've been looking at in the research is those coupling technologies that link a hydrogen or natural gas system and an electricity system. So we've been looking at technologies like electrolyzers, technologies like direct combustion of hydrogen, but also combined heat and power as a interaction or coupling technology. And then one that isn't mentioned very much is the nuclear sector and the potential for pink hydrogen, as well as that excess wind generation at times when the electricity demand is low, but the wind generation is high. So I think those are all important interactions in terms of where does the hydrogen come from, but there's also interactions in relation to where does the hydrogen end up being used, and whether that's the industrial sectors, whether that's transport applications, or whether that is in heat decarbonisation, all of those things will interact. And so as we see demand for hydrogen in certain sectors increase, that means potentially less hydrogen available for some of the other end users until the generation of hydrogen can catch up again. So these are all interactions that we're looking at as part of the research.
Lovely, thanks, Sarah. I'm actually going to move on to the second question now, which is how can a decarbonised energy system meet peak heat demand? And Michael, if you could take that question first, that would be good.
Yeah, no, thanks, Chris. And I think, I echo a lot of just what's been said around question one, and recognise that we have an amazing natural resource in the North Sea and the wind within it that can create enormous amounts of energy. Unfortunately, there's not an amazing correlation between when that energy is most available and when it's most needed. And so I think, therefore, this all becomes about how are you able to kind of match those things and build an efficient system that's able to meet peak demand. And clearly, we all want electricity when we want to turn the lights on, and we want heat when it's cold. And so I think the important thing is that kind of holistic design that enables the least amount of infrastructure to be built, because ultimately the vast majority of the energy producing infrastructure is going to have a kind of a zero fuel cost. It's going to be wind or it's going to be solar. And therefore, the way that you kind of build a system that is least cost to everybody and most resilient is one that has the least amount of infrastructure. And what I mentioned, 500, 600 gigawatts of offshore wind is an awful lot. And so, if we want to build a system that is capable of meeting those coincidental demands that come together between electricity, heat, and transport, we need to build a system that's capable of storing energy across the seasons. And I think the research we've done here is really kind of is demonstrating that hydrogen is an incredibly useful vector because it can be transformed from one form to another. It can be produced from a number of sources, and it can be used for a number of end cases. And therefore, kind of we see that making use of the existing gas infrastructure, which would also include some of the things like the disused oil and gas fields in the North Sea for either hydrogen storage or CO2 storage, ultimately enables the most efficient route to net zero, while also creating a system that is resilient to those very cold weeks when there's a huge amount of heat demand, but there's not very much wind.
Thanks, Michael. And Sarah, from a technology perspective, maybe how would you answer the question.
Yeah, so in order to meet peak heat demand, one thing to start off with is to reduce the peak through insulation. And the second, in terms of our energy systems, is to make sure that that heat demand delivery mechanism is as efficient as possible, i.e. the system in the house or in the building is as efficient as possible. And then the energy delivered to that system to enable it to operate needs to be decarbonised. And so there's a range of technologies that are possible. The Element Energy report that did the balanced pathway, which is the one used in the government's net zero and the Committee on Climate Change work, has a mixture of hydrogen ready boilers, heat pumps, some of which are hybrid with hydrogen, with solar thermal and with electric resistive. And so there's a mix of technologies in the scenarios that the government is using. There is no one technology that's going to be perfect for every single situation. It needs to be all possible solutions tailored to the context of the application. And that's why hydrogen is an important element of our future system. It can't all be heat pumps. It can't all be hydrogen. It needs to be a balanced portfolio, including solar thermal as well, which isn't mentioned very often, unfortunately, in some of the policy documents. But I think a first stage is to reduce that peak heat demand. The difficulty with that is that it's down to the homeowner to make that investment compared to other parts of the energy system making the investment in the energy generation side of things.
I think that's a really good point around the customer. But Barnaby, can I ask your perspective on the question?
Sure. I mean, from my point of view, I mean, if you look at take it from a kind of first steps, heat pumps are really efficient. And that's well recognised in years, sort of 300% efficient and all that. So if you all else being equal, you would start with heat pumps. But as Sarah's just saying, these things aren't equal. Not all homes are as energy efficient as each other, and also you would have to then carry that electricity, which would have to be instantaneously generated, to the demand. And as Keith was saying at the start, that implies a huge amount of reinforcement of the electricity infrastructure, and that may not be the most efficient way to take things forward. So yeah, absolutely. So you need to have a range of solutions depending on the infrastructure locally, the types of housing or whatever, whether it's industry or commercial buildings, in order to deliver heat in the most efficient way, given the infrastructure we currently have today. So in some places it may be, yeah, we should be doing heat pumps. Other places, okay, let's use the existing gas infrastructure, upgrade it as we need to, which shouldn't be too expensive in most cases, and I think the report makes that point as well. So yeah, it's a range of choice. I think the other thing to point out is if we do go down the electrification route, we do need to generate that electricity. We need to decarbonize the electricity system. If you have a cold day, you're having high demand on the system, electricity system, where do you get that from? And again, this I think where is hydrogen can come in as well, because you can obviously generate hydrogen electricity from hydrogen either through combustion in hydrogen CCGT or through I would imagine be very large fuel cells. So in either case, I see a hugely important role for hydrogen. But in terms of generating heat directly, as Sarah was saying, we need a range of options depending on the specifics of the user and their behaviour and infrastructure.
Thanks very much. And I think Sarah makes a great point. For the 38 years of my career thus far, the Holy Grail has been energy efficiency and driving down that energy need. And at some point, we've got to make that a serious thing within the decarbonisation debate. I think part of the challenge will also be, as you look at the energy sector and not just the sector for heat, is making sure that you don't drive new peaks, for example, with rapid EV charging within the system. When I used to run the control centre back at the late 20,000s, you still had a peak at 1 o'clock in the morning, which was a legacy to the Economy 7 tariff, which hadn't been actually in existence since the mid to late 1980s. That peak was still there. So I think designing the system is going to be absolutely key in thinking about all usages and driving that efficiency. So I'm going to move on to the next question. And
sorry, Chris, sorry, would you allow me a couple of follow-ups on the previous comments?
Of course.
Sorry, the first one was just with regard to the upfront costs, and one of the reasons that hydrogen would be an attractive model from that perspective is that most of the investment needed would actually be carried out by the regulated monopoly distribution and gas distribution companies, where it's much easier to finance that sort of investment than for each individual to have to do it. Because if you look at hydrogen ready boilers, once they come in numbers, the manufacturers have already said that they will be no more expensive than a standard boiler. Therefore, you can actually achieve the conversion without all of the big upfront capital costs. And I think what we need to remember is the situation we're looking at is not that we're going to flick a switch and suddenly we're in a new world. We have a long transition period to go through. We have to manage that transition over probably a couple of decades, and therefore the transition is as important a consideration, if not more of an important consideration, than where we get to at the other end. So that was just that one point, and the other was just with regard to a number of points that Barnaby's made. Just reflect the electrocentric world that we're in at the moment, because you're thinking about what happens to the electricity price in conjunction with making hydrogen, or that's one of the drivers for making hydrogen. There's another model where you don't actually make the electricity per se. You have a rotating turbine which happens to be able to make hydrogen without ever having to see the electricity that comes out of that. It's sort of like a black box that produces the hydrogen. And in that world, you don't have the issues of price cannibalization. You don't have you have basically a high or nearly 100% capital cost driven hydrogen production model, rather than one that is dependent on some sort of commodity with a variable price. And that's a very different model to think about. And I've seen quite a lot of analysis which shows that that's actually a much more attractive one, because you avoid all of the costs, as was said earlier on, of the electricity infrastructure. In offshore wind, a third of the cost of offshore wind is the cabling and the conversion in the substations. So removing that actually removes a very big component of the cost. And if you're not replacing that with anything nearly as expensive for transporting the hydrogen, then that can actually be a very attractive way of doing it. So I just wanted to point out that how important it is that we A, think about the transition, and B, think about what the world might look like and how it will be measured, rather than what it looks like today and how it's measured and managed. Sorry.
No, thank you for that, Keith. So I'm going to divert the next question to Sarah first, given that we've just had that feedback, Keith. So what are the technical and policy challenges, the use of hydrogen for interseasonal storage? This is a big question. I'm sorry about that.
No, that's fine. I think one of the technical challenges that we're looking at is the actual storage itself. So we've mentioned the use of empty oil and gas fields. We've mentioned salt caverns. At the same time as we're thinking about those facilities for hydrogen storage, we're thinking about those facilities for carbon capture and storage, and they can't do both. So a technical and policy challenge is deciding which possible storage volumes are going to be used for which gas. That's a policy challenge, not just a technical challenge, but also in terms of technical challenges. At the moment, it's quite difficult to predict the future in terms of what the peak heat demand will be, because there's a combination of heat demand being met by heat pumps, with some uncertainty in the coefficient of performance and the demand curve for those, and therefore for the locations where hydrogen is likely to be used around industrial clusters, with hydrogen boilers in those locations, it's not quite clear by 2050 exactly how much heat demand that is going to be at peak. So there's a lot of assumptions and uncertainties in modelling to try and get some kind of good estimate of what this might look like from a technical point of view, to then know how much hydrogen we need, how much storage we need for that, based on how many houses or how much demand we think will be met by hydrogen compared to other technologies. So it's all quite complicated, because it's not just, you don't just look at hydrogen in isolation, you have to understand what's happening with other possible technologies to then know how much hydrogen's role might look like in different scenarios.
Absolutely, absolutely. So Barnaby, can I come to you next on that question?
So I'll pick sort of one technical and one policy. I think on the policy challenge, as I was just saying, we haven't done this before. There's a huge amount of uncertainty, and if we're going to look at large-scale storage, we don't have the business models in place. We don't know how much it's going to cost exactly. So how do we move to a world quite rapidly where we're utilising these large geological stores to store hydrogen? We don't know exactly what demand will be, what the market's going to look like. So I think we probably need to be looking at kind of what is the business model that will enable hydrogen storage at large scale and in the long term. And do we need something like we have with interconnectors, a cap and floor mechanism, or some other sort of support just to get things moving? So that needs to be addressed, because at the moment, I don't think we're going to see the investment in the volume of storage that we need without some sort of clarity over the long term. On the technical side, it depends. What are we going to be using this hydrogen for? If it's going to be for combustion, there's not too many issues. But if it's going to be used for fuel cells, for transport, that sort of thing, you need quite high grades of purity. So how do we make sure that once you store the hydrogen, you maintain that purity? If it's in an old oil and gas store, are you going to be losing some of that quality of the hydrogen? And similarly, are you mixing electrolytic hydrogen with blue hydrogen or grey hydrogen, which may not, again, have those levels of purity? So those are sort of the technical challenges we need to be thinking about as well. So a few things we still need to iron out.
Thank you, Barnaby. Michael, can I come to you?
Yeah, thanks. No, and I think it brings all those points together, really. To me, I think what we really need is somebody looking at the energy system as a whole, and not thinking about traditional markets and how to sort of maximize returns in those traditional markets. It's about, how do we kind of put those things together in a very different modern setting to how those markets were originally set up, in very siloed fossil fuel based worlds. And so we do need something like a kind of system architect or controlling mind, and then we do need to think about how we create business models for the competitive players in those markets that allow them to kind of drive efficiency and do the right thing, but also to be able to make a reasonable return. But to all the points that were being made, that means we need to think about what prices are going to do in a world where broadly speaking the prices are fixed, because you're on some kind of mechanism to cover the cost of the infrastructure, because the fuel price is typically going to be zero. So to me, it's all about that kind of, we need to ultimately redesign an energy system rather than, a power system, a transport system, a heat system, a gas system.
Thanks, Mike. Keith, is anything to add?
Yeah, I just wanted to highlight what I think one of the key points here is, and that is the economics of interseasonal storage. And I would add to that also inter-year storage, because actually Interseasonal storage is probably require tens of terawatt hours. If we go into year storage with the variations that you see across the years, you're well over 100 terawatt hours that you're going to have to store. And that's why you need these big geological stores, as we've had in the past. So I would slightly disagree with Barnaby that on that point, that we have had natural gas storage in the tens of terawatt hours with fields like Rough. But the problem with Rough was that there wasn't sufficient value attached to that seasonal storage and to that strategic storage to make it worthwhile for Centre to keep it going. And one of the issues that we need to think about going forward is that at the moment, the cost of storage of fossil fuels is covered within the fuel price, and it's typically very low. Even for seasonal storage, it's still relatively low. So people don't see that price because it's covered within the overall fuel price, and therefore we tend not to value or even notice the functionality that is being provided by that. Now, in an electricity world, that's not the case because all of the storage and the necessary infrastructure is covered outside the levelized cost of electricity. And what we're not doing at the moment is putting sufficient question marks about how much that element of electrification is going to cost going forward. And the idea of having a battery that you use only once every 5 years and at the costs of that is just an impossible one. You need something which is a tiny fraction, several orders of magnitude less than a battery cost or even pumped storage cost if it's going to be worthwhile doing interseasonal or inter-year storage. And at the moment, the only thing that comes close to that is gas storage or hydrogen storage, which might be 2 or 3 times more expensive due to the lower energy density, but it's still in the right order of magnitude. It's not 3 or 4 orders of magnitude askew, as is the case with batteries and pumped storage and other electromechanical storage facilities. So we need to get to grips with that. We need to understand that this is a particular challenge, and this is a political challenge because it's one of those things that you probably like fire insurance. You know, when that rare occasion of the fire comes, you really want to have that insurance in place. But it's awfully tempting in the short term. Say, well, you know, maybe I don't have that. And these are the sorts of political decisions about strategic reserves that will be needed. And in the absence of international supply chains that we have for natural gas, which means that we can get away with less physical storage in the UK. If that doesn't develop, then we will need to look very seriously at these large interseasonal, inter-year storage facilities.
Thanks, Keith. And you know, for if you want to see the economic drivers for storage, I think the European lack of filling of storage during the summer months this year demonstrates what happens in terms of price realization. But how do you, as you quite rightly say, get that thinking into investments into the energy system rather than waiting for the consequence to happen? I'm going to move to Slido at this point and some of the questions that are coming through. And the first one I'm going to ask the panel, and Sarah, if I can ask you to take this first, is how did the panel think industry can engage with end customers to ensure energy efficiency becomes a priority?
I don't think it's the role of industry. I think it's the role of government and policy to drive that, and for industry to be the service provider. But it needs the correct market incentives put in place for the end user to engage with that industry that's providing the retrofit through government support and policy mechanisms to make it affordable. I don't think it should be an industry driver. I think it should be a policy pull
That's good. I'm going to actually move on to another question, which is, Michael, if I can throw this one at you first, are we suggesting a patchwork of individual houses with different technologies, or are we saying that certain areas or regions will be electrified or green gas?
Yeah, no. So we've done some analysis on the on the housing stock makeup in GB, and you know, the applicability or lack of for different heating technologies. And I think there is a very high prevalence in Great Britain of relatively old houses, and we also have relatively high population density, which means that retrofit of heat pumps is going to be probably more challenging than in many other geographies around the world. I think for that reason, we generally found it quite hard to see that you would find large pockets that could therefore be completely disconnected from the gas infrastructure and could be substantially electrified. So you probably do end up in a world where it is a bit of a patchwork. There may be streets or small regions where there is a prevalence of a more modern housing stock, which allows for greater heat pump retrofit. But essentially, our view is that there is enough of a critical mass of properties that would require a hydrogen connection, such that those that are currently connected probably have a choice if they want to stay on, and that therefore you're likely to see a customer preference, possibly more towards a like-for-like switch out of a boiler-based system. So I suppose where you end up then, it is more in that sort of patchwork world. It's probably also worth mentioning hybrids, and that we could well end up in a world where people have, or some people at least, where they have the space, have both, and continue to have a gas connection, but also have a heat pump that either can, cover the shoulder months and the hot water alone, or something similar.
Thanks, Michael. And Keith, if I can ask you, is the future system operator the system architect?
I don't think that necessarily are, just like you wouldn't have the architect running things day to day. They're there for a particular purpose. I think that for me, we need to split things up. There are decisions that need to be made politically. There's then, once that has been done, the design of what it's actually going to look like. And I think that's where the architect comes in. There's then delivery, which I think is a separate exercise again. And then once you've delivered, there's the day-to-day operation and maintenance and running of the system. So for me, those are four discrete steps that we need to think about. All of them are really important, and but I don't think that we do ourselves any favor by trying to shoehorn many of those four into one organization. I think that each organization is, or there are organizations best suited to each of those functions, and therefore I would not see the design coming from the operator.
There's the following question has come on very quickly onto Slido. They're saying, if not the FSO, future system operator, then who is the architect?
I think it is an architect for me is somebody who pulls together all the expertise from the different specialized groups, and pulls that together into a design. And so that may involve working with a system operator or others, bringing in the expertise for that design process. But there are plenty of engineers who are designing things. But when I worked for SSE, we had engineers who designed things who weren't working in the control center. The control center was was doing a real-time management of the system, which is a very different type of exercise to the engineering that goes into the design of the projects, or indeed the delivery of those projects. So I don't see it being anything particularly new, other than that at the moment it's all a bit muddied, and I feel we need to have a greater clarity about where that expertise should lie.
Thanks, Keith. I'm going to go back to the questions on the slide. And the last question, Barnaby, if I can go to you first, what impact do we think that the COP26 Glargo Pacts will have on the role of hydrogen in our future energy system?
That's a big question. I mean, I think that sort of two things, I guess three things that really came out of it for me were, one is, we finally got discussions of phasing down coal in the system, and as well as addressing the level of subsidies for the oil and gas sector. So that would imply, and we need to reduce our reliance on fossil fuels, and that makes it quite clear. And I think that the Glasgow Pact, I hope, will accelerate that. But we need to replace that with something. And I think the challenge we have is that, frankly, gas and coal are great for energy. If you just look at that, they store it really well in high density. It's easily transportable. That's why we use it so much. But we need to replace that. And if it wasn't for the minor climate change problem, we wouldn't be having to talk. But we need to replace it with something that can fulfill those roles. And hydrogen and its derivatives, whether it's bioethanol or bioethanol, but synthetic fuels or ammonia, can replace gas and coal in that sense. So I think that's going to be a hugely important role. And then the other side of it is it specifies using more renewables. So that is great, but again, we need to produce, or we can't always be using renewables just for electricity, as Keith was saying. It will do other things, and producing hydrogen is going to be kind of a key part of that, whether it's part of an integrated electricity grid or sort of as dedicated generation as well, hydrogen production. So those are my sort of two key things. I mean, really, we need to move away from fossil fuels. Hydrogen is going to be the way we do that, and I think the Glasgow Pact, just carries us on that journey.
Thank you, Barnaby. Michael, if I can go to you next.
Yeah, no, I completely agree with that. I think if anything, it's the catalyst that means that there's now a real need to replace, particularly coal, but I think natural gas will be the inevitable kind of follow-on fuel that comes under scrutiny next, with something else, and and that can't all be renewable electricity. I think Barnaby's point is absolutely right. What you want is something that has a lot of the characteristics of fossil fuel, in that it's movable, it's stable, it's storable, it's combustible, and works for the applications in which we currently use those. And I think hydrogen kind of provides an awful lot of that. There's obviously some challenges, technical challenges and economic challenges to come over. But as a vector, as a concept, it's fantastic. And I think hopefully now we're moving on to arguments about how we create business models, or overcome some technical challenges rather than the necessity of it in the first place, which I think is a huge step forward.
Thank you, Michael. Sarah?
So I think the Glasgow Pact means that the role of hydrogen needs to recognise that hydrogen also needs to be decarbonised for it to have a role moving forward, and also for us to consider the global implications of the Glasgow Pact and the potential for our understanding of the role of hydrogen to inform other countries and to help them on the road to decarbonisation. I think the Glasgow Pact and some of the discussions and the media coverage has also shown us that urgency is becoming more recognised now. And so I think we need the role of hydrogen to be accelerated in order to help support delivery of a 1.5 degree climate change impact. And so for me, it's those two. It's the acceleration in the use of hydrogen and development of the role of hydrogen, and it's the clean hydrogen. And both of those will help other countries outside of the UK to learn from our experiences.
Thanks, Sarah. And Keith?
Yeah, unlike many, I wasn't particularly disappointed by COP26, but that's because I set my expectations down about zero. I don't think that it's going to make any sort of step change around hydrogen. I think perhaps it's, as with the various other things, it was discussed during the 2 weeks in the media, it was discussed in others, so it got more prominence. Perhaps that's helped a bit. I think it's also highlighted the international work that's going on with hydrogen, which has now, you know, from being one of the leaders in thinking about hydrogen, I think the UK's probably slipped back now, and other countries are moving faster, and that will maybe help to accelerate things here. But directly, I don't think COP has made any major difference to how we see the role of hydrogen in the energy system.
Thanks, Keith. I'll give my my view on this as well. Is I actually think, you know, what it has highlighted is the need for pace and a sense of urgency. And I guess if I've got one hope, it's that that urgency doesn't decrease as we go through the next year before the next conference over in Egypt. I think for me, that urgency drives a more systemic view of what we're trying to do and what we're trying to achieve. And I just would rather like politicians to be brave in their decision making. And I know that is a real challenge. You know, the inherent incentives in politics doesn't necessarily make for brave decision making, as we've witnessed over the last few weeks and longer, kind of in that. But for me, it sort of drives a groundswell. I think that people are looking for solutions and want the drivers to do that. And what we have, and has been reflected by the discussion that we've had here, is a very technical debate and discussion around our energy system, as you would expect from us as professionals in the sector, I think, because it is for us to solve those problems, to help the policymakers make those decisions, and then allow customers. I was going to say choices, but we had quite an interesting discussion earlier around choices versus decisions. And, you know, at the moment, customers really don't have a choice and therefore aren't prepared to make decisions. And I think, you know, one of the things that will heighten is that demand. And I think those of us of an older generation see it through the younger generation around what they are willing to and not willing to engage in terms of their futures. So in an odd sort of way, like you, Keith, I actually felt quite positive coming out. And why? Because, you know, we're pointing in the right direction. We haven't got everybody to exactly the same place, but they are at least all pointing in the same direction, which gives hope, in my view, for getting to the right place. So that's my version of the question 4. We have very nicely come towards the end of the time here on how can hydrogen help create a system for all seasons. So I'm just going to quickly ask if the presenters have any last points they want to make. And if not, sorry, Keith.
Yeah, I would just like to see us breaking out of the chicken and egg at the moment, where saying, oh, we're not going to produce any hydrogen because there's not enough demand for it, and the users saying, well, we would use it if somebody was producing it. I think we really need to understand that no matter what, there is likely to be significant demand for hydrogen, and if it's not there existing at the moment, it will be created through all of the policy necessities that we see for climate change. So I would like there to be a greater focus on building up the production facilities for hydrogen, for low carbon and zero carbon hydrogen, and see more urgency in that. That would be my plea.
Yeah, I'd agree, and completely agree with your point, Chris, around pace. You know, if you want to be a world leader, and you know, just in terms of kind of keeping in the 1.5 degrees, we just have to get on with this. We don't need endless debate and analytics and points of view. It's obvious that you know, hydrogen has a huge role to play, and therefore we should just be getting on with it.
I think just to add to that, you know, we need that pace, so we don't have time to kind of trial stuff. And yeah, my instinct is to let the market deliver and take, you know, it'll happen. We don't have time. You know, we need to get on with this, and I think there's a hugely important role for government to set out the ambition, which then I think the private sector will then step in and fund. But we can't wait sort of another 15 years for this to kind of to steadily pick up. We need to get going, particularly because the UK is currently really well placed. We are slipping behind, but we're really well placed to kind of take a lead in this, and I worry we'll lose it.
Yeah, I agree. I think it's an exciting time to be involved in the energy sector because so much change is needed. We'll not always get those changes right. We have to accept that sometimes we will make mistakes as we move forward. But the worst thing we can do is do nothing.
Thank you very much. And a big thank you to all of the panel members this morning, Barnaby, Sarah, Keith, and Michael. I really appreciate your views and your candor. I would point, and this is just part of the ongoing debate, I think, that will help to inform the decision-making process, I hope. I would commend anybody that hasn't had the opportunity thus far to read the document, to have a read of the document. I think it reads very well. And if you have any questions that you want to follow up on, then please do contact us through the E&A. And apologies, Ed, but I suggest that you direct those at Ed Gill, who has been the mastermind behind organising this webinar. So a big thanks to you also, Ed. So it only remains for me to thank everybody